So this is Stupid Ideas for Mini Computers. I am ThagamiserRB on Twitter. My phone is nowhere near the podium, so you can't interrupt me if you tweet at me, but I love tweets, so you should do that. My first Rubyconf was San Francisco in 2009, and Aaron Patterson and Ryan Davis gave this talk. That is a recreation of the actual title slide for that talk, by the way, and if you haven't watched it, go find it on Confreaks. It is still one of my absolute favorite conference talks ever. And basically, the thesis of this talk was Aaron and Ryan had been riding the bus together a lot. And while they were on the bus, they came up with a lot of really bad ideas that they then implemented for some reason that none of us have figured out yet. And then they shared perfectly good code, including tests and responsible network usage and stuff for these awful ideas they had. The classic one being Fubi on fails, which was Rails running on PHP, if I remember correctly. It was awful. And it worked, which is the terrifying part. So at the time, I was in QA, and my tests lab looked a fair amount like this. It wasn't actually racked up. It was sitting on a rolling cart. But now I work at Google, and so this is what I have access to for doing any of my stupid ideas. So clearly, it's time for this talk to be redone as worst ideas ever at scale. So a little bit about me. I'm Aja Hammerly. I'm on GitHub as Thagamiser. All the code for this talk is in my examples repo. I pushed it up this morning. And I blog at thagamiser.com. So sometimes I'm getting paid to blog now, so it happens slightly more than 3 times a year, but not much. I work on Google Cloud Platform. This is probably the second time. I'll mention that one more time during this talk. But if you have questions about running your apps in a cloud that is not the one you are currently using most likely, come talk to me. I have credits, I have stickers, I have lots of things. And whenever I go to conferences, I bring a bunch of plastic dinosaurs. So if you want a dinosaur, you can come get a dinosaur from me later. And because I work at Google, I have to say this. Unless otherwise stated, all code in this talk is copyright Google and licensed Apache v2, because lawyers. So now that I've done that part that I had to do, time to get to the stupid. No, really, now it's going to get dumb. Load testing. So this is the unless otherwise stated part. The code in this section actually predates my employment at Google by quite a bit, and so it is actually licensed MIT, and it is not in that repo. If you want it, please don't. Just don't want it. It's really bad, because this is really, really stupid load testing. I started my career in QA. I worked in QA on very understaffed teams at very small companies, and they would be like, hey, can you go load test the app? And I'm like, what do you mean by that? And they're like, load test it. And I'm like, well, what are you trying to find out? Load test, oh, fine, okay. So I went to Seattle RB, and I'm like, okay, well, the real problem of load testing is that I need to have a bunch of computers and make them do things that look like users. And in this case, I had a Rails log of the scenario I wanted to test. And it was a Rails log. And I had one tool in my toolbox at that point, pretty much, and that was Mechanize. And let's just be clear, I am a wizard at Mechanize. I have done some awful things with Mechanize, many of which I will not admit, but were also going to be included in this talk until someone told me that that was a bad idea, because they were, yeah, well, you can ask me about that later if we're drinking. So 2 reasons I decided to turn my Rails log into a Mechanize script. One is that it allowed me to parameterize it a bit, so I could inject different user IDs, so I wasn't replaying the same scenario as the same user 1,000 times in parallel, because it turns out databases don't like that very much in ways that are not actually useful when you're doing load testing. And also, by taking that giant Rails log and pulling it down to just the bits I cared about and making them into a Mechanize script, it made it so I had a much smaller bit of code that I had to push out to a distributed computing environment. And because I needed to generate this load for a while, this is a fantastic load testing technique that I do not recommend, and I have used on production systems more than once. Infinite loops. So yeah, I've showed you some basic ideas, but load testing or something. This is not load testing. Please, please, please don't think this is load testing. So what does the code to do this look like? Well, let's be clear. It's not good. This is some of the very first Ruby code I ever wrote that I have not killed yet. Like, it needs to die in a fire, but it's still kind of useful, so I haven't. And to drive that point home, this is the first line of that file. No, really, that is actually the first line. So here's some code. There's a tiny bit that I pulled out, just kind of focus on a section at a time. This is a basic preamble. If you need to get closer, it's OK. I don't bite. And all I'm doing here is requiring mechanize, creating a mechanize agent, loading a login page. Really simple stuff. But I'm not actually doing those things. I'm metaprogramming. I'm writing code that will do those things. And then I open up a Rails log file, and I look for lines that match that horrible regex. That horrible regex is looking for lines that start with parameters, and it's extracting the action, the controller, and the params that were sent to that controller. And then I do some logic based on that and write something out. It happened to be that this particular app that I was testing, 97% of the Rails requests went to one of two actions. And so I just decided to figure out, was it action A or action B? And I ignored everything else, because everything else after login was entirely irrelevant to my use case. Because if you're going to load test 97% of your app, not the other 3%. But sadly, this technique is flexible. I found some code this morning where I had used this in the last year. Don't know what I was thinking. I know better now. I know better tools now, but I have. You're pulling out the action, the controller, and the parameters, so you can smash together any sort of request you need to. You can even pull out the HTTP verb if you want, and you can really pull out anything you need to. But I've just showed you how to do a basic record playback test at this point. I haven't actually showed you how to do the load part. So how do you generate load? That's the magic word you're supposed to say, but really you just do it a bunch of times at the same time. So back to our friend, the infinite loop. And yeah, there are companies that you have heard of where I have used this technique to test their code, and that's a little terrifying. And then the other big thing is I just used bash. We talked about Unix a couple times this morning. I just wrote a bash script that started my mechanize script up 30 to 50 times, depending on how big the machine I was on was, and let it go. And the first time I did this, I was running on commodity hardware that had been purchased off eBay, big old pizza box servers with aluminum casings, and they got warm enough that I could have made a toasty cheese sandwich on the casings. I was relegated to a conference room with a rolly cart with a bunch of Ubuntu servers balanced on it, and they made me close the door because it was too loud with all the servers running while I was testing. I didn't make the sandwich, and I kind of regret that now. But the second time, and the fifth time, and the 8th time we did this, we just used VMs in the cloud. There's a bunch of cloud providers. We provisioned a VM once, put Ruby on it, put the gems we needed on it, and then we clicked the button that said make more like this one until we had enough load. And I'm supposed to call this section deployment, but deployment implies a degree of organization and intention that I did not have at that time. This was really just pure hackery. We're like, we need to deploy this next week to production. We have no idea if it will stand up to load. Let's take 5 hammers and see if we can pound this screw into the wall with these 5 hammers. So I used VMs. Had to SSH into the VMs in order to start this bash script up. But that let me ramp up the load slowly, because it was a manual process. So I just called it a feature. So to be clear, this is stupid. Why is this a stupid idea? You did not have at that result. You might know if your server fails, if it falls over. But if half of your mechanized agents don't start up, you have no idea. If they time out and crash halfway through, you have no idea. Another reason this is stupid, there are off-the-shelf tools that are free that you can do this with. Apache Bench exists. There are a lot of expensive tools that do this. They do it much better, but you could. If you have VMs and you have Ruby, you have all these tools. But please don't, but you could. So 1 stupid idea down, 2 stupid ideas to go. This stupid idea is courtesy of my boss. My boss and I were chatting over coffee one day. He's like, I have this idea for this awesome interview question. He goes, I'm going to ask candidates if they can do sentiment analysis on a series of tweets using emoji. And I'm like, that is the dumbest idea I have ever heard, and I love your question, and can I please use it in a talk? And he said yes. So thank you to my boss for letting me use his interview question in a talk. If you are ever interviewed by my boss and get this question, this is not the right answer. I want to be really clear on that. This is the stupidest answer that I could come up with. So if you're not familiar with sentiment analysis, it is the process of computationally identifying and categorizing the opinions expressed in a piece of text. especially in order to determine whether the writer's attitude toward a particular topic or product is positive, negative, or neutral. And it is hard. True sentiment analysis is really hard because humans aren't very precise with language. So if someone says this sentence, sure, I'd love to, with a smile and their eyebrows go up a little bit, you think they're probably sincere. If your teenage son says it, accompanied by an eye roll, probably not so sincere. And the sentiment of that second one is probably much more negative than the first. But we don't live in a world of just words now. We use emoji and emoticons. And they aren't necessarily any easier to detect the sentiment on, but they're newer, so maybe we haven't gotten as much subtlety in how they're used. So let's see what it would look like if we tried to categorize these 5 into positive or negative. You might end up with something that looks like this. So the heart, the thumbs up, and the smiley face are positive, the pile of poop, and the devil face are negative. And yes, part of the reason I'm doing this is so I could use the pile of poop emoji on slides again. So, I'll be real honest about my motivations here. But if you think about it a little bit, maybe the thumbs up is a little less positive than the heart, or maybe the pile of poo is a little more negative than the purple devil head guy. So maybe something like this is more accurate, where you've got a continuum from positive to negative of numeric values, and you're going to assign a given emoji a numeric value about where it goes on the continuum. And if I'm going to do sentiment analysis, I also need a corpus of text. I don't have access to people's SMS where they're going to put emoticons because I'm not the US government. So we can use tweets instead. So here's the code. I had to use the Twitter gem to pull tweets down. So if you've ever used a web service, this is code to grab 1,000 tweets at a time. I have a key, I have a secret, I connect to the Twitter service, and I search for some sort of query. It turns in this case that I was searching for the hashtag happy. So hashtag happy. I figured that that would be likely to have emoticons or emoji in it, right? And I can pull down a bunch of tweets, and I'm just throwing them out to standard out, and I'm using Unix file redirection to throw them out to a file, so I can do work on them later. Here's the code to analyze a tweet. I am going through the sentiments collection, and if a tweet includes a given sentiment, I am adding the value associated with that emoji or emoticon to the sentiment of the tweet. And where does the sentiments constant come from? It comes from a separate file because encodings are a pain in the butt, and I only wanted one file that had to be encoded UTF-8. And my editor does not show me the emoji, so I just have these strangely spaced white blocks in my editor. So I just throw them in a separate file so I can require them in later. So this is all wonderful and nice, but this is a talk about doing stupid ideas at scale. So just far, we've only talked about doing a stupid idea. So how do you scale this up to many computers? Ryan told me, and this is really cool, that Rinda is a library that exists inside standard lib in Ruby. And Rinda is an implementation of Linda, which is a distributed coordination language. Rinda is the Ruby version. It's part of standard lib, no gems required. And the way Linda works at a very, very high level is that you have what is called a shared tuple space. It is basically a server that holds a collection of tuples. If you've ever used Python, you've heard of tuples, because Pythonistas love themselves some tuples. And this is what that looks like. I've got this kind of cloudy tuple space thing, and I've got these arrays. And I'm going to represent my tuples so that the first thing in the array is a symbol that says what kind of tuple it is, and the rest of it is the payload. And for all the examples I'm giving, the payload is a single element. Sometimes it's a string, sometimes it's a numeric. In later examples, sometimes it'll be another kind of object. And then there's a bunch of workers, and they can take things out of the tuple space, and they can put things into the tuple space. If they take something out, maybe they do some work on it and transform it, and then they put a different value into the tuple space. And this just allows them all to coordinate, so I can have as many workers as I want, and they can have the same job or different jobs, and it all just kind of works magically. And the coolest part is how little code you need to make this work in Ruby. So the thing that maintains the tuple space is the Rinda server, and that is all the code you need to set up a Rinda server on your machine right now. In Ruby 2.2, this works great. 4 lines, and you have this space that you can connect to with a bunch of different agents and do whatever you want in distributed computing fashion. I made this slightly more complicated than the minimum example by letting you pass the URI you wanted to have your server on as a command line arg. You didn't even have to do that. For the tweets, I have 3 worker types. The first one is the fetcher. It feeds tweets into the tuple space. It's going to feed in tuples that look like this. The first symbol is tweet. The rest of it is the body. The second part is the body. Here's the code that does that. That line that I'm highlighting is where the tweet gets written into the tuple space. The first 5-ish lines almost identical to the server. It's just setting up a DRB connection and connecting to the tuple space. And then this line, if you are astute, you have noticed that I'm not actually connecting to Twitter here. I am reading the tweets in from that file that I created earlier, because it turns out Twitter is really, really good at rate limiting. And I ran out of time before this talk to figure out a way to get my rate increased in such a way that I didn't actually run afoul of Twitter, because I'm a nice person and don't want to actually take denial of service anyone's stuff. So that's all it is. It just writes a bunch of tweets into the tuple space. The next step in the pipeline is the analyzer. If you're familiar with MapReduce, this is the mapper. And it's going to take the tweets out of the tuple space and then write the sentiment of that tweet into the tuple space. So here's the code. Again, the first 5-ish lines are just connecting to Rinda. They're almost identical to the server and identical to what the fetcher was doing. Then I have an infinite loop. And inside that infinite loop, I've emphasized 2 lines. The first one is ts tuplespace.take, where I am removing anything that meets the pattern, an array of 2 elements with the symbol tweet as the first element, and a string as the second element. And I'm saving the string as the variable tweet. I then go through my sentiment code that I showed earlier. It's exactly the same. And then the last line, I am writing to the tuple space an array where the first symbol is the symbol, or the first element is the symbol sentiment, and the second value is the numeric sentiment of that tweet, which means it might look something like this. The sentiment might be the numeric value 5. And finally, I need a reducer. In the MapReduce system, reducers are things that take a large collection and make them a slightly smaller collection or a single element. In Ruby, we call this inject. It's also alias to reduce. There's a reason for that. I'm going to use my reducer to take all of those tuples that start with sentiment and collect them all and get the overall sentiment for all the tweets. Here's the code that does that. Same 5 lines, 4 lines at the beginning to connect to Rinda, a variable for the total sentiment that's running, and then I just take everything that starts with sentiment out of the tuple space, add it to my ongoing total sentiment value, and then I'm putting it out to standard out. Because the way I deployed this, I had access to standard out. I could see what the value was, and it was that simple. So here's how this looks in diagram form if you're more visual. I start out with a tweet, and the fetcher pulls it in, puts it in the tuple space. The analyzer takes it, and then puts a sentiment in the tuple space. And then the reducer pulls the sentiment out, and then updates the total sentiment with that value. So it's just a pipeline, but it's going through a shared memory space, basically, on the way. So again, I've only talked about how to do this in theory. I haven't talked about how you might do this at scale. And the answer to that is clearly containers. If you have been to any conferences this year, I am positive that you have heard a talk about containers, probably Docker. I was reading Slack the other day, and someone said that they've been to 14 conferences this year, and every single conference has had at least one speaker do a talk about containers. So containers, clearly the right answer. Yes. I'm using the latest Ruby container, the Ruby latest container from Docker Hub, because I am lazy. I implemented this with 8 containers because I was doing a relatively small number of tweets. 1,000 containers. Once you have more than 2, going up to 100 or 1,000 is not actually hard. That's kind of the joy of computer science. We have 3 numbers, 0, 1, and many, right? If you can do many, all kinds of many are about the same level of difficulty. I distributed these containers on 5 VMs. I can distribute them on however many I want. That seemed like a good idea. Here's basically what it looks like. There's a single fetcher, a single reducer, a single Rinda server, and then a bunch of analyzers. I used Kubernetes, which is a product that came out of Google Cloud. It is a container orchestration thing. Basically, you tell it you have these VMs, you want to run these containers, and it makes that go. And I like things that make that go so I can hand wave away all of the networky stuff. I can talk a lot about Kubernetes, but that isn't this talk, so I'm not going to. The big thing is that I laid it out, and it figured out one way to put the containers on the VMs that made sense. I don't have any control over where they go, and I don't have to care, and that's awesome. So I ran this, I figured it out, and the answer is, for the tweets I pulled down, the sentiment was 202, which is a positive number, which makes sense because I was searching for the hashtag happy. So clearly this is a totally reasonable way to do sentiment analysis on Twitter, and not stupid at all. Yeah. So for my last trick, I'm going to do combinatorics, because combinatorics. So who's heard of a Latin square before? Awesome, OK. Ryan heard about Latin squares on the plane yesterday. So Latin squares is an experiment. Latin squares are an n by n array that are filled with different symbols, each occurring exactly once in each row and exactly once in each column. Looks a bit like this. This is a 4x4. This is a 7x7. I found this in Wikimedia Commons, and I'm like, oh, it's at one of the colleges in Cambridge. It must be old. It was actually installed in 1989, so it is less compelling than I thought. But Latin squares are named Latin squares because of Euler. Yes, really, that Euler. He wrote papers about them, and he used Latin characters as his symbols. So that's why they're Latin squares. They're simple. You all understand Latin squares at this point. And the math's pretty easy. So 4x4, how many different Latin squares are there? Anyone want to throw out a guess? How many possible 4x4 Latin squares? More than 1,000 or less than 1,000? Raise your hand if you think more than 1,000. OK, you're all right. There's 576. So if you go up to 6x6, it's not much bigger. When I was testing this code, I'm like, hey, 4x4 is working. I'll try 6x6. Turns out 6x6 is actually, there's a lot more 6x6 Latin squares. In fact, there are this many 6x6 Latin squares. Oh yeah, I'm going to show the math. It's awesome. It's even worse than shoes is the best part. So 9x9 Latin squares. 9x9 Latin squares are actually really cool because Sudoku is a special case of a 9x9 Latin square. It has an additional set of constraints. But every Sudoku that's solved is a 9x9 Latin square. And that right there is the number of possible 9x9 Sudoku, or 9x9 Latin squares, which is approximately that. And to put that in perspective, that is more stars than there are in the Milky Way, and only slightly less, only 2 orders of magnitude less than there are stars in the known universe. So that's a big number, really big number. So how do we generate Latin squares? Because clearly I want to be able to generate Latin squares. Logic problem. So I'm going to use a sieve approach. If you've ever generated primes with the sieve of Arithmeses, same idea. You just generate a bunch of stuff, and then you decide which ones don't actually work. And I'm doing this because I am fundamentally lazy. I coded up all the code for both the Twitter and the Latin squares in less than 2 hours total once Ryan told me that Rinda existed. And because I'm fundamentally lazy, I'm going to use array permute because it's awesome. And so here's the code that will generate possibilities for Latin squares. I take in an arg that is the size of the Latin square. I make an array from 1 to n. I take all the permutations of that. And then I take all the permutations of size n of the permutations, and I put them out to standard out. And those are possible Latin squares. So here's one of them. And if you look carefully, this one's not actually a Latin square because there are 3 1s in the first column. And I did math on the airplane last night. So if this is wrong, you can tell me because I'm not entirely sure. But that is the number of possibilities that I am generating that I need to sieve through. And that's a lot of bangs. That's a lot of factorials. So if I do this for 5, I end up with that many. So 22 billion that I'm going to have to sort through for Latin squares of size 5. And there are not 22 billion Latin squares of size 5. There are several orders of magnitude less than that. So clearly I need to figure out if one of the things I generated was a Latin square. So here's how I check them. I'm taking a solution out of the tuple space, because I'm going to use Rinda again. I figure out how big it is by looking at how long the first row is. I then make an example, which is a sorted array from 1 to n. And then I check if all the rows match that, when I've sorted them, match that array. And then I use transpose to rotate the array 90 degrees. And then I check and see if all the columns, which are now the rows, when sorted, match that array. And if they do, it's a Latin square. So I put it out to standard out. So walking through it like that, that's the rows. That's the columns and output. So yeah, 22 billion. Clearly, I can't do that on this machine. I tried. It doesn't go well. It really, really doesn't. So I need to scale, obviously. I'm going to use Rinda. That's what I'm going to put in for my possibilities, things that my generator is going to generate. And then I'm going to put my solutions back into the tuple space that way. So here's the server, same code. Interesting fact, I can have the same server solving 2 separate problems as long as the tuple spaces don't overlap. Here's the generator. I already showed you the code for hooking up to a Rinda server. I already showed you the code for creating these things. Instead of writing to standard out, I'm just writing to the tuple space. And here's a case where I'm using an object as my second argument as opposed to something simpler. Even though it's Ruby, people still think about strings and numerics as being simpler than objects like arrays and hashes. Here's the checker. Here's the line where I'm taking something out of the tuple space. And yeah, that's it. It's really stupid simple how easy this was to do something horrible, horrible. So the deployment. So how do I actually do this? Exactly the same as before. Here's an architecture diagram, this time in a circle. Here's a Kubernetes diagram, this time with 6 VMs. So at this point, I have about 5 minutes left. So I'm going to have some profound thoughts to share about, stupidity. So was any of the ideas that I discussed today useful? No, not a one of them. No. Were any of them well engineered? No, not really. I have tests, actually, for several of these, just because the original talk, they wrote tests for all their horrible ideas, and it seemed like a good idea. But no. So were any of these the correct tool? Heck no. There are off-the-shelf tools that are open source for doing both load testing and sentiment analysis. Please don't do it the way I did it. And there are also numerous published algorithms for solving Sudokus and solving Latin squares. And they're much, much better than this. You saw that giant equation with lots of n-bangs? That is approximately the big O runtime of this algorithm. And so it's big O of n factorial to n factorial. No. Those factorials add up fast. Were these fun to hack together? Heck yeah. This was, instead of do the simplest thing that could possibly work that Ryan's going to bring up in his talk later today, this was do the stupidest thing that could possibly work. I tried to come up with as little code I could write in the most ridiculous way to solve these problems. I didn't quite have robots feeding things to each other, but it was close. And the best part was it was really fast to write. Not particularly fast to run, but yeah, the Rinda code for both of the Rinda examples took me less than 2 hours. The load testing code was from a long time ago, but even then I got most of it hacked together in a single Seattle RB meeting. And the deployment and networking was the hardest part. Networks are hard, and I'm not particularly skilled in that area, but it was still very doable. And the thing that I've been really noticing as part of doing this talk, but also part of my job at Google, is that the way people are thinking about computing is changing. We don't think about, when I grew up, this was a computer, right? And I currently walk around most days with 4 processors in my bag, and that does not include my iPad and my phone. And I walk around with a relatively lightweight dev stack compared to a lot of folks, because I like the MacBook Air. So what is a computer now? At where I work, we talk about it in terms of disk and I/O and memory, and those things don't even have to be located in the same building. And that's probably true for a lot of you. You just don't think about it that way because you go out and buy a VM, but you don't think about the fact that the 2 VMs you're buying may not even be in the same rack. They're not in the same rack. They may not even be in the same building. In some cases, they may not even be at the same site, depending on exactly how your particular cloud provider defines region and zone. And I'm starting to think that computers are kind of just the sum of their parts at this point, when networking is fast enough that we can interchange those parts in many different ways. And it's making the limits of what we can solve and what is a practical solution to something very, very weird. The fact that all of these solutions were practical, for some definition of practical, is kind of disturbing. I haven't even been in tech that long, and I couldn't have even thought about doing this 5 to 10 years ago. But the real big thing is don't be afraid to have fun. Don't be afraid to do something stupid for the sake of playing with a new idea. So thank you. And one last thing, I am giving this talk in about a month, and I'm giving it to a much bigger audience. So if there are things that didn't make sense or that you would like to give me feedback on, please share feedback, because I need to redo it. And that's how you can do that. And I will take questions and or hand out stickers and or dinosaurs. So yes.